recording. Hi there. Welcome to February's RCOP. This month we've got three universities talking about how they've handled CUI on HPC. So all of the acronyms, but in case you need more, they've all been hitting the NIST 800-171 compliance regulations on their HPC servers and clusters. And we'll be getting to hear more about what's going on in each of these spaces. But first, if it's your first time here, please sign in. NSF does care how many we have each time, and it's a great stat to start promoting that. Next slide. Quick update that we have a new item or new thing going, and it's pretty much called Ask the Assessor. What we're doing in that space is talking with Fraser and Dieter, and we're asking them random questions that are on all of our minds. And so our first question, we started off easy, was essentially, can a single enclave house more than one type of data classification? And right now it's in their shop. They're excited to see it, and we will hopefully have a response fairly soon and put that on the website and promote it in these venues too. Next slide. Right now, there's some fun big news coming up with EDUCAUSE security professionals or cybersecurity professionals privacy conference. Does not roll off my tongue, but anyhow. The call for proposals is open through the 18th. I really encourage all of you to get something in. It's going to be a good venue to talk to each other in person and network for the whole day. But we also already have an accepted workshop there. So RCOP will be hosting a full day workshop titled Avoiding Shelfware, Building Sustainable Research Compliance Documentation. And essentially it's what happens after you get to your assessment, and how do you make this a living document that all these teams might have to support and contribute to. And so in addition, we also have some good funding available that we have to spend out. And yeah, apply for that. So next slide. The other ones I wanted to get on your radar is there's a few things coming up in the CMMC type of space, mixed reviews on some of them, but there's the dates. A really exciting one is next month's RCOP is going to be AFRL chatting with how they are able to handle some of the hosted research that they're offering. So if you have contracts with AFRL, I really encourage you come back for next month's. And then after that, we have creating the cybersecurity office. And this has been a thing that's a few institutions have now discovered they need to do after NSPM 33 and what was the fallout there. So some exciting ones coming up, and there you go. So hand that over to Lewis on what's happening today.
So we have heard the interest in HPC, and so we approached three institutions that are all going to speak on the various HPC solutions that they've implemented. I think this will give everyone a very good overview. For each of these, they'll be presenting from 10 to 15 minutes each, and then we will take questions at the end. We have created in the agenda a question section, so if you want to make sure that your question is captured so you don't have to remember it, please feel free to add in your question in the agenda, and then we'll go through and ask those questions. I'd like to turn it over to Purdue University to start with. Preston, if you'd like to start talking, that'd be great. Introduce yourself, and then we can start your slides.
Okay, great. Thank you. My name is Preston Smith. I'm the Executive Director for the Rosen Center for Advanced Computing at Purdue University. And I've got my colleague Sandeep Rao here, who's our Senior Director of Technology, I think you're called now. So I'm going to talk about our backstory, how we first came to be supporting 800-171 HPC here, how that's evolved. And then Sandeep is also going to touch briefly. We're going to take a brief diversion into the not HPC part of it, because we think that's important to think about it as a whole ecosystem. So if we go ahead and start the first slide here. Hit next. Okay, so I'm going to breeze through these first couple of slides because the long time our COP attendees may have seen some of this material before. So we got our first taste into doing 801.71 HPC in 2015. We had a small on-prem cluster for the couple of ITAR contracts that were here. And one of those researchers, the sponsor came back to him and said, you've got this great ongoing project that you already have. We've changed the requirements. You need to be compliant with the new DFAR 7012 clause and therefore 801.71, and they would not negotiate it away. So next slide. So we were very new at this at the time. We had to thought about, do we need physical, restricted data centers? What all is in scope? Do we need fully FedRAMP? Do we need to make our own FedRAMP environment? We turned to GovCloud. I know one of the other talks is going to be about using the cloud. So we did our first take on this in the cloud. We use AWS GovCloud, and the most important piece, we were in compliant by the deadline, and we're able to continue with that project. Next slide. We created a system called READ, Research Environment for Encumbered Data. So it was a hardened system built in GovCloud that allows for processing with data with strict regulations. Next slide. It was a lovely technological terror. We met every one of the 801.71 controls with technical answers. So we were technically compliant, but practically not great. We were able to get the work done, but the faculty were really displeased with it. Next slide. So one of the next things that we did is we immediately pivoted to re-architecting for a variety of reasons. It was really expensive doing this in the cloud the way that we did it. It was not very cloud native. It was very much like people would run on-prem computers all the time. Real dollars left the university. We didn't take advantage of existing subsidies. It was one-off processes. We didn't have the cloud expertise in place, and it was onerous to the researcher. If they complained to your VPR and your CIO and the president about how terrible the environment is for doing that research, it was pretty clear to us that we missed the mark. Next slide. So we set off, and when Carolyn was at Purdue, she was leading a lot of this effort. So thanks to her for all that leadership. We set off to replace READ with a new environment, building on a lot of the lessons that we've learned, using standard processes, things that we had in place. Use less technical controls. Use policy where you can. Have long-term storage options, reducing cost variability. Faculty don't like to get charged direct cloud cost if they didn't plan for it. There's a lot I could say about the financial aspects of that, because I think that's some of the most compelling pieces of it. I won't go into that here, but I will refer back to I don't know if you can find on the website one of the first webinars, which I think was also real well received at the time, about the financial aspects. And I think that's the piece that you should definitely consider as you're working on your 801.71 HPC environment. Next slide. So we're good now, right? So we've made this more cost effective. We learned some lessons on the usability. It turns out, no, we weren't quite right. The people with computational workflows had their stuff taken care of. But everybody else, the experimentalists in particular, they wanted desktops and Microsoft Word and PowerPoint, and being able to talk with their sponsor on a Teams call. And Sandeep will chime in here at the end and talk a little bit about that. What we were able to do is making that researcher edit their PowerPoint inside of a VM inside of the supercomputer, is just not a good user experience. All the HPC folks out here, can you imagine having to edit your document inside of a VM on your supercomputer on a day-to-day basis? The faculty didn't really like it either. So this diagram kind of shows a picture of what we want our ecosystem to evolve to. So moving on. So how does this look in practice on Weber, which is the name of our DoD CUI machine? So at a really casual view, without looking too closely under the covers, it looks a lot like our open systems, but with major differences of it's behind a tight VPN, like you can't even get to the login nodes without first using the VPN. It's got very tight ingress and egress controls, so SCP or Globus was not possible. And there's almost no outbound connectivity once you're inside there. So pulling stuff down from GitHub or other places like that are impossible. But there are some pain points in practice. So if you're the researcher or the system operator, there's controls for doing software reviews, which are required to do. But those are hard. They're labor intensive. And how practical are they? Given that I always joke whenever we get a new CISO, I always introduce myself and say, "Hi, I'm the guy with the $1 million arbitrary code execution platform." And that's kind of what we do here. So how do you review every little bit of thing that might run on your supercomputer? Is that Python script or the MATLAB file? Is that code or is that user data? If there's controls for connectivity whitelisting, so accessing URLs and stuff, you construct how you do that carefully. What we did a combination of IP tables, a squid cache, and layer 3 firewalls. So every time a PI needs to get to a website, you've got to go back and forth and iterate repeatedly to get all these things in sync so they can access DoD safe or whatever it turns out to be. So a layer 7 firewall would have been way better. We have a complex inbox and outbox process, that's illustrated there on the right, where you both people turn the key at the same time to launch your file. We required everybody to use a VDI to do things like preventing copy and paste. And then there's all sorts of scoping implications when we're doing this on the DoD side. If you bring your Active Directory into scope, you then have citizenship requirements you got to worry about. Is one of the admins that runs your identity office, are they a non-citizen? All sorts of challenges with that. So moving on. Probably one of the reasons many of you are here is because we've had some recent new policies from the NIH side, where the NIH GDS policy is requiring 800-171 as well. So this, of course, creates more work for us as well, even though we already have a CUI, an 800-171 environment. We knew of over 30 contracts that are subject to this policy at Purdue today, and today they were using a variety of systems. They were maybe using our open clusters, maybe they were using departmental machines, maybe their laptops, and other projects, in all sorts of other domains that could use restricted data. We know that they're computationally intensive, so a VM with a STIG applied to it isn't going to cut it. It wouldn't be a great experience for tightening down our big open systems. We couldn't necessarily use Weber. There was some concerns about the different revisions of 800-171 maybe not being compatible. And frankly, at the end of the day, the DoD CUI system has citizenship requirements. So we can't exclude all our non-US people doing biomedical research. So we're led to another enclave. So what we're going to try to do better with that, moving on to the next slide, is try to make the user experience better. Continue to make that better for the user. We want to use similar VPN, the standard 2-factor. We want to make it so that just like using a regular supercomputer, that once you VPN'd in, you can use SSH, open on demand, and all those other things that contribute to the quality of life. The user will get controls applied for things like malware scanning and blacklists, and audit logs, working in the access zone on the login nodes. Then the typoed compute zone there will be where where the user does the work, and then we take advantage of Globus HA for data egress and ingress without that complicated process. So next slide, I found this this HPC standard to be a valuable tool. So use this as you're working with your compliance office, having a NIST standard to reference, why your compute zone and your storage zone are different and have different threat profiles and characteristics as your login zone has been really, really valuable when I talk to the CISO's office about how we need to set these things up. Next slide. Just touching on some of I'll try to blow through these pretty quickly. We're just some stuff about how we plan on doing the networking, and making sure that that's leveraging existing investments and user friendly. The next slide, I think, is the access and compute zone. Where we want to put malware scanning and all that sort of stuff in the right place on the where it can work with minimal impact. Keep it off of the compute zone where it might impact the applications. and not running external services where, where it's not fitting. Next slide. On the storage, we've got a couple of different storage options with different characteristics, all of which are encrypted. We've used ZFS on Weber, and we're going to use that again here. We have an encrypted Lustre for high performance needs, and also an encrypted HPSS archive with Globus HA again as the tool for that. And I think one more slide, and I think, yeah, then this is where I turn it over to Sandeep for the all important guidance is that make sure they don't forget about all the other things that are not HPC.
So yes, we did talk about the fact that this was an HPC related webinar, but the reality is that HPC is just the foundational piece. You need the HPC, but it is completely pointless, and as far as the faculty are concerned, if you do not give them a decent interface to work with, which is what Preston alluded to before as well. So in a lot of places, what I see is that people are not tackling the monkey. If you haven't heard this analogy, it's a pretty sweet one. If your job is to have on display a monkey that recites Shakespeare, then incremental progress dictates that you have plans for setting up a stage, plans for building the pedestal, figuring out how to sell the tickets and whatnot. And then you come up to the monkey and then you go, oh, I don't have a monkey. But then you have the ability to show that your project was on time, you hit all the milestones, all the things were great because you crossed all the T's and dotted all the I's. At the end of the day, what's the point? You don't have said monkey. So moral of the story is, if you don't deal with the endpoints, you're doomed to failure. You have to include the endpoints in your planning, in your scoping. And like I said at the bottom there, right? If you do not twitch when you hear the word endpoint, you're doing it wrong. So moral of the story is, make sure that you have your endpoints properly thought of. Make sure that you have the appropriate pieces around it. So underneath everything is this broad base of HPC, right? But on top of that, you need to have collaboration tools. You can't not do that in today's world. So you have to have something like GCC High wrapped around that. Then you need to have a full tunnel VPN in front of it that allows seamless access to both the HPC storage as well as your GCC High, so that you can actually do your PowerPoints, do your stuff, get your certificates, and then send your emails out as you need to deal with it. Active Directory is critical. You have to have your Active Directory worried about. So you need to have your Azure VDI, you need to have your Active Directory. You cannot have all your data acquisition machines labeled as special assets. By the time you get done with that, you will have so many special assets that if I were coming in as an auditor, I would poke very hard, right? So you've got to have planning for that. So at the end of that tunnel, you have your networking group, you have VLANs that are specific, you need to have MAC filtering, you need to have specific machines that are allowed on those networks so that they can be considered inside, be able to get in. So there's layers upon layers upon layers to this. So the non-Windows pieces are also critical, because the majority of us are going to have at least a subset of people who are engineering faculty who will come in with Linux needs. So you've got to have Linux endpoints figured out as well. And if y'all know anything about Active Directory, y'all will know that it is a brick tied to one small helium balloon when it comes to non-Windows machines, trying to authenticate, trying to basically exist in a Windows world. Can it be done? Yes. Is it great? Arguably. If it works for you, great. It doesn't work for me. So yeah. And then Mac OS. Mac OS is probably one of the easier ones to deal with, because if you use something like Jamf, there's a one-click mechanism to get them to any one of the CMMC levels using XML files that you can pick up and just kind of apply. And then finally, I would say that you should have at least access to one full stack person. So those are your pieces that you need outside of the HPC to make sure that your faculty do not come after you with that proverbially famous torches and pitchforks conversation. So if you go to the next slide. So if you look at this kind of a diagram, you'll notice that in the middle bottom right is our HPC Weber. So that's to the right of the 4 arrows box. That's our HPC. As far as when I'm dealing with faculty members is concerned, our HPC lies there, and the rest of the things is what we have to worry about. In our current state, we do not allow CUI data to reside on endpoints, but we are absolutely traveling breakneck speed at making our endpoints able to hold actual CUI so that they can do work in a more seamless manner. And we're hoping to get that done by the end of this year. So that's where Purdue is. Preston, I kept it under 3 hours.
Doing great.
Thank you both. We have 2 other presentations, so hopefully we'll have time to get to some of the great questions that have arisen. I'd like to give Ryan a chance to introduce himself and begin his talk.
Great. Hi, I'm Ryan Dytman. I'm with the University of Arizona. That's in southern Arizona in Tucson. I am the program manager for what we call our Controlled and Regulated Research Services program. Really long, we call ourselves CRISP for short. And today we'll talk about our journey to CUI HPC. Next slide. So today we'll cover quickly, we'll go through what our service offerings are at this point. We'll talk about how we got started with CUI HPC, what our timeline looked like. We'll cover some of the critical controls that we came across and some lessons learned along the way. Next slide. So we got started similar to Purdue. We launched our services in AWS GovCloud. This is with EC2, which is the virtual machines, and S3, which is their storage solution. And we had a compliant system ready by the end of 2017. We've been operating in AWS GovCloud ever since that time. We also deploy in GovCloud Cisco networking. This is for our VPN appliances are hosted in GovCloud, as well as a completely separate Active Directory. Preston and Sandeep talked a little bit about this, that separation from your enterprise Active Directory. So we don't bring that enterprise AD into scope. We've created a completely separate AD. And then just in the last 2 years, we have also ventured into the GCC High realm. We support GCC High connection through our AWS solutions, basically they're virtual machines in the cloud. We also have a small number of physical devices that are also configured to store, transmit, and process CUI. Those machines are also allowed to access 365. Next slide. So we got started down this road as we had a number of researchers who were using DoD HPC systems. If you're familiar with DoD HPC systems, it does require sponsorship in order to get on one of the machines. That sponsorship isn't always easy to obtain. And then, as with any large data sets, moving data around was tedious and slow. So we had some researchers on our campus who were wanting to solve this problem for research projects that they had going on. And they submitted a grant proposal with the Department of Navy. That process started pretty early with our team to help gather requirements. We had to determine decide whether or not they wanted GPUs or not. We talked about people time because it does take people to run HPCs. After all of those conversations, we moved into getting some quotes from different vendors. Once we got some idea what the cost would look like, we created a budget and then submitted all that information to our researchers, who then compiled it with all the other grant information that needed to go along with it. And then a long wait to hear back from the granting agency. And eventually we did. So we did hear back in the affirmative and moved forward with continuing our process. So we started this around mid-2022. By December of that year, we had our first kickoff meeting. And these orders for the equipment were placed around February, March of 2023, with our firewalls being purchased much later on, and we'll talk about the reasoning for that. We started our compliance documentation, and no surprise, this is the element that took the longest to get through. We started that in May of 23, and it took until May of 24 to complete that documentation. Along that way, we don't have a dedicated GRC tool, but we have a wiki that we use for our documentation. During the time when we were writing this documentation, of course, our hardware arrived, so it was racking and stacking that hardware, but really not any configuration because we were still working through the controls. Since we were gonna utilize our existing Active Directory environment for authentication and access, a lot of those controls we could already assume. We had to make some minor adjustments to those, but generally we use those existing controls, so that saved some time. But configuration management and maintenance and media protection, physical controls, we had to actually write some physical controls because all of our stuff was in AWS. We didn't have a lot of physical controls. System communication protection, system and information integrity controls, as well as architectural diagrams. All of those controls took quite some time to document. As we talk about firewalls, we were going through our documentation, so we had in our minds an idea of what firewall appliance, what functionality we wanted out of the firewalls, and we were marching down the road of a particular set of firewall models. But as we were digging into these controls, particularly the system communication protection and the system and information integrity controls, we realized that the firewall that we were thinking wasn't gonna meet some of these controls and some of the things that we wanted to do. And so that brought us back to the drawing board a little bit to rethink what that firewall would look like. One of the last bits that we did as far as our configuration goes was those firewall egress rules. As Sandeep mentioned, it's a lot of back and forth with researchers trying to understand what URLs need to be open in order to access things like DoD safe. The other things we had were security configuration. So we have an existing scene that we use. We host that in AWS. So we have some integration we had to do with that scene. We also had to set up new alerts and new reports. We worked with our security operations center in order to do that. We have a security operations center on site that we use for these services. Software installation was also one of the last tasks we had, because it takes some time to get licenses, get license managers to work these things. Once we had, software installed, we had some preliminary, firewall rules. What we decided to do was open the HPC up for some preliminary testing, but we did not authorize any CUI to be processed, stored, transmitted on the HPC. And we did that because we wanted to make sure that usability functions worked, that controls we had in place worked. And so we had researchers use some test data that was non-controlled data. We used this to test the authentication and access function, to test the scheduler, test running jobs, what do the jobs look like, transmitting data in and out of the cluster. And then, of course, refining the firewall egress rules. We ran our firewalls in a monitor mode so that we could detect what URLs researchers were accessing and utilizing on the HPC. After that testing, then we, this was in June of last year of 2024, we developed a go live checklist. And on that go live checklist, we wanted to validate some things to be sure that we were ready to go live. So we validated that FIPS encryption was enabled, validated that we were able to collect logs, validating our egress rules and our file permissions, validating who actually had sudo access, validating port restrictions, and then VPN access as well. And then we had our go live date of July of 2024. Next slide. So some of the critical controls, obviously access and authentication is a very critical set of controls. As I mentioned earlier, we were able to utilize our existing Active Directory in this environment. So a lot of the controls were already written and we could take advantage of those. We had to write some new controls for media protection because of having physical appliances in a data center. So that took a little bit of time to write some of those controls. Again, physical controls, since we didn't have physical infrastructure in the past, we had to write some of those. Fortunately, we have a research data center, which is separate from our enterprise and co-location data centers. So they were already locked down, but we had to go through and just refine those policies as well. Maintenance controls, we had to document what our maintenance schedule is. For the HPC, we do that maintenance quarterly. If we were to do that on a monthly basis, research would never get done on the HPC. So we had to document that quarterly maintenance, the reasons for choosing a quarterly maintenance. Under configuration management, and also in the access control, there's the FIPS 140 -2 encryption requirement. We normally on our HPCs, we use Rocky Linux, but Rocky wasn't FIPS validated, at least at that time. So we had to go with a different version of Linux, and we went with Oracle Linux, which was validated. So that's an important piece to keep in mind is the operating system, making sure that the encryption modules are validated. Also, principles of least privilege, we have to make sure that those were in place, port restrictions. As I mentioned, the security side, encryption, big one. Make sure architectural designs were in place and made sense. And then firewall rules, we spent quite a bit of time going through firewall rules and configuring those. Under system and information integrity, there's a section about virus and malware scanning. How we're going to handle that on an HPC. So on our HPCs, we run applications like Arcade Hunter for rootkit detection. We ingest those logs into our scene. We run AID for any unauthorized post-configuration changes against the baseline, and those are also ingested into our scene. We have Audit D running on our systems, and this is for logging unauthorized access to password protected files and home directories. We ingest that information into our scene as well. And then we have written in our technology control plans for those who use the HPC that files have to be scanned on a secure endpoint prior to being transferred into the HPC system. So that's how we're handling right now the virus and malware scanning. Is it's scanned before it's transmitted or transferred into the HPC. So as far as our next slide, as far as lessons learned, as true for everything in 800-171, documentation takes the longest time, and it's so critical, important. So plan for it taking longer than you expect. If there are controls that you can reuse from your existing CUI services, reuse as much as you can, and that will save a lot of time as well. Keep your researchers informed and up to date as to progress, because they are anxious to get on these systems. So we learned the importance of communication and keeping them up to date. Would recommend that you allow use of the system before CUI is put on the machine. This will prevent any sort of accidental, disclosure of data. It allow you to test functionality, allow you to test your scheduler, your access layer, those things. Stress that pretty highly. It's pretty important lesson learned for us. Take the time it takes to do the URL and port filtering. It does take time. It does take a lot of back and forth. Make sure your researchers understand that it may not work right at first. It may take digging into the URLs to understand things a little more. And I would recommend that you draft your system and communication protection and your system and information integrity families of controls before deciding on your firewall appliance. This will help you to really understand and document those controls, understand the flows of data, and what you need to have in place, what kinds of tooling, licensing, functionality you want out of your HPC. And those are our lessons learned. And then there's contact information if you have additional questions.
Thank you very much, Ryan. We will now move to our next presenter, which is the University of Michigan. We have Jim Kenyon.
Good afternoon. This is decidedly less technical and more about a journey from having only a desktop CUI environment to meet very basic compute CUI compute requirements to how do we meet HPC requirements for researchers who need to address that need. Traditionally, our HPC requirements were met by researchers who were using either the sponsors or another organization's HPC environments, and that's turning out to not be the case here. We have a large center that's spinning up and other grants and contracts that need HPC resources. So we want to be able to accept those, and that brings us to the scene of the crash, as it were. Briefly, what are the goals? Why did we take the decision to go cloud-based initially? How did we build out the team? What challenges did we encounter? What did we learn, and where are we headed? Next slide, Lewis. What did we look at first? We wanted to limit our upfront investment because we really don't have a good view on what in the commercial world, what the sales pipeline looks like for inbound grants and contracts with CUI requirements are. We need to have the resource available on demand, and it needs to scale with money. pay as you go. Given the current situation with indirects, that may not be a bad situation to be in. So we need to have CUI compliance for HPC resources for the College of Engineering because PIs have grants and contracts that require them, and the sponsor is not providing that resource. The computational requirements are greater than our CUI enclave can provide. We provide basic VMs, bespoke VMs in the handful of cores and tens of gigabytes of RAM, not in the multi-node, hundreds of cores arrangement that an HPC cluster would provide. We do have two primary clusters on campus. One is for unrestricted research. The other is for HIPAA-aligned research. Decidedly, neither of those are CUI, much less CMMC compliant. Next slide, Lewis. Again, the goal, comply with CUI with an eye towards CMMC. When we started this endeavor, CMMC was a glimmer. It is now a reality. So we're looking at what can we do for CMMC. We want to be able to accept these grants and not get sideways with regulators. And we want to be able to do large scale CUI projects. Again, we have a large center with Space Force that's spinning up here, and they have large simulations that need HPC resources, but potentially, and 3 or 4 other College of Engineering researchers who have similar needs. And an indeterminate amount of what I'll call DB gap, the genomics NIH research that while it isn't CMMC, it walks like a monkey. Thanks, Sandeep. I really like that. You've given me a new arrow for my quiver. Next slide, Lois. Why did we decide to go to the cloud? Cost and financial concerns. We didn't have a credible demand forecast. And one of the things that you go to the cloud for is, I don't know how much I'm going to need. I don't want to go to leadership with gee, I think I need to sink in several $1 million in capital, but I can't really tell you why. I don't have any solid numbers to justify it. So cloud. I know it's going to cost me more per drink, but I'm gonna at least limit my upfront costs. We also need to be able to have thin provisioning. Let's be able to do this quickly on demand. We also have very limited historical demand data. We just haven't had many researchers who didn't come with external access to HPC. So I don't have forecast data. I don't have historical data. I can't really build a good business case for this. Let's get some traction on data and see what this looks like. The other was time constraints. We need to be able to move more quickly than we could take the 2 to 3 years to build this out on premise. I saw in the chat conversations about data centers. That's a real thing. Where do you find this space? We're already looking at another data center for I don't know if anybody's followed the news lately, but we're building out a large data center to support a national lab partnering with state of Michigan and the university. That's 6 years out, 5, 6 years out. This stuff takes time. So ability to move quickly. Next slide. More, scale up, scale out. Same reasons everybody looks at going to the cloud. How do I do this quickly? How do I do it efficiently? And do it with limited demand information. The asterisk on this is once you know what your demand information looks like, as a research institution, your cost of money is much lower at scale than cloud, or it can be. So it's likely that we'll repatriate this once we see what our scale looks like. So, we'll find out. But right now, cloud. Here's a key part. Back to implementation team, Lois. We really looked at, because this was initially very College of Engineering focused, point of need, there's a heavy focus on College of Engineering, but you'll note on the right-hand side of this slide, and I'm not reading slides to you, you all can read. We didn't want to paint this into a College of Engineering corner. This isn't, I mean, Michigan's a big campus, but let's not try to shove square pegs through round holes. Let's make sure that the solution is generalizable enough so that large engineering fluid dynamics simulations don't preclude large scale, high throughput genomics work or image analysis from light sheet microscopy in the future. We need to find something that's generally supportable for all of our researchers, but available today. So the team was comprised of primarily College of Engineering research or College of Engineering staff, but also representative from campus, along with key vendor contacts, both technical and administrative. And we're really keeping an eye for, let's not replicate this. If you are an anarcho-confederacy like Michigan is, you will find that services get replicated around campus. We're trying not to do that. We don't want 4 different HPC environments for CUI or NIST 800-171 compliance more generally. We want one. Everybody use it. Next slide. Challenges. I wanted to put up the heavily redacted version of this slide with just black lines through it. There's an inside joke here. The mantra at Michigan is, at Michigan, we don't talk about Fight Club. We are pretty circumspect about what we do and don't talk about. So this slide doesn't have a lot on it. Maybe what's missing from here is more telling. One of the things you will encounter with moving to the cloud is software licensing. Not everything that you have negotiated for a very attractive research software license price is fungible, portable to the cloud. Watch out for that. If you do have licenses that are portable to the cloud, how fast can you consume them with the number of cores available to you in the cloud? I know Abacus came up as one of these titles. You can consume all of your Abacus licenses in the cloud very quickly and have none of them available for your on-prem cluster in very, very quick order. So watch out for how you consume them and whether or not they're portable. It's going to take time to work with all your vendors to sort that bit out. Internal approval delays. Here's the heavily redacted bit. I'll say that you need to work with your internal teams who touch the approval of any contract you have with an external vendor in this space. We have been working with a concierge service for HPC services. That's a relatively narrow market space, and the folks inside the institution who need to touch this and negotiate these contracts, as you might guess, have limited experience in that space. Make sure you leave a lot of room for all of those people who are not your IT people to sort out those contracts. It takes time. And in general, 800-171 is a new thing to many people. This compliance space is novel. Give yourself time for all the people involved on the team to get accustomed to working in this regulatory space. You may speak it fluently. Chances are very good that these other teams do not speak it fluently. Those were the big challenges. Technology was not the big challenge. Big lessons learned. Engage your stakeholders early. Be flexible. Look for ways to mitigate risk. Big risks are contract negotiation, procurement pipeline issues. Look to educate your stakeholders. That's particularly around the regulatory frameworks and how public cloud works. Public cloud is different than buying hardware from Dell. It's a different thing. So those are our big things we learned. Next slide, Louis. Where we're headed. We are looking at ways of scaling this. I mentioned maybe repatriate it. We have to find out what the run rate usage looks like. We have to eat some of the dog food before we know what that looks like. That gets rolled into a business plan for leadership. We're working with cloud partners. In fact, we're letting another RFP for a CUI compliant enclave environment that will help inform this learning. It's the requirements for CMMC have been interesting for us generally. We've run our own CUI enclave for a while. CMMC level 2 caused us to reassess a little bit and say, how does this really work for us and what does it really cost? How do we meet these controls? It's been an interesting journey. Next slide, Louis. We have a signed agreement. It took us a while, but we got here. We have a base CUI offering almost available. Training is getting scheduled for administrators. Pipeline your contract negotiations. Don't wait. Get your contract negotiation people working on this when you start. Don't wait until you've got things mostly lined up. This fourth bullet, I can't stress this one enough. Define your personas or use cases before you really dig too hard into this. Who is going to be using this? If you don't have really a firm understanding of this, at least get a general idea of who your use cases are. This will help with your vendors or when you're outlining this. We didn't have a good definition of who and what the use cases were going to be, and it made it difficult for working with the vendors when we were engaging them because it was just too squishy. If you can collect prior use case information, this was a problem for us. We don't have good tracking information locally. Back to an anarcho confederacy. I think the joke, Louis can correct me. We have 19 schools and colleges who share a football team and very little else. Yeah. You know, we don't have good tagged information about what is ITAR, what grants and contracts are ITAR encumbered or CUI encumbered, or you know, what regulatory frameworks are around them, how much money is tied to them. Identify your pipeline of prospective grants and contracts that are encumbered by these different regulatory frameworks. That kind of information is what builds the business plan that drives leadership signing off on spending money. Those were big challenges for us. That was fast, but we're short on time. Louis, last slide, I think. I'd say thanks to our friends from Arizona and from Indiana. I joke about West Lafayette. For your West Lafayette folks, I grew up about an hour south of you in a little town that hosts DePaul. I grew up on the borderline between being an Indiana fan and a Purdue fan. So I know all the jokes about being buried in the sidewalk outside Mackey Arena.
Won't hold it against you. You turned out okay.
Yeah, I moved to Michigan.
All right. I want to thank our three groups of presenters. As you can see, we ran out of time. We'll ask the presenters to review the questions that either came up in chat or are on our agenda, and we'll get them to submit answers that you'll be able to view in the future. I'm sorry that we didn't have enough time to be able to cover all of the questions. But again, I want to thank the presenters. You see, we have 3 HPCs, all in various stages. So you guys have an idea of kind of the timeline and the decision-making processes and what's involved in setting those up. Carolyn, I'll turn it back over to you.
I really have nothing more than thanks. This was amazing. I can't believe the turnout. And yes, we were very chatty in all of the venues, which means there's plenty to collect. So probably more on this. Seems like we have more to talk about.
Hey, Carolyn, would you plug the Slack again? Because that's a place where the conversations can happen differently even than the collected questions and answers directly related to the presentation today.
I will count that as the plug for it and include links to it.